Well, good morning and welcome, everybody. Thank you for joining us for this webinar today. My name is Ryan Blazik. I'm with EGLE's Environmental Support Division. Just going to help moderate today's webinar. And this webinar is part of a webinar series, the 50 Years of the Clean Water Act web series. So we have one webinar each week, each Tuesday for the first 3 weeks of October to celebrate the 50th anniversary of the Clean Water Act. You can find out more information by going to www.michigan.gov/CWA50. This is the second webinar on the web series. It's on the success stories of the Clean Water Act in Michigan. But before we get too far, just have a couple logistical things to go through. All lines are going to be muted during the webinar, so you'll be able to hear everything we say, but we won't be able to hear you. If you have a question at any time, you can submit your question in the Q&A box in your Zoom toolbar. We have 4 success stories, and we're going to wait until the very end to go through the questions, though. And we're going to have a question and answer panel at the end. And then also, just to let you know, we are recording the webinar in case you miss parts or want to forward it on. It'll be on our YouTube channel and posted here in a couple days. With that, to kick things off, I would like to invite Phil Argeroff, who's the Assistant Division Director for Water Resources Division in EGLE. Welcome, Phil.
Thanks a lot, Ryan. It's really good to be here today. Last week, we talked about the history and the structure of the Clean Water Act. And this week, we're talking about some of the success stories and how vital this act has been for protection of the water environment. These success stories stretch across both sides of our program: protection of resources, as well as protection of pollution, discharges and control programs. So we're going to have 4 really good stories. I'm going to briefly describe them here. And I want you to join us next week too. And next week on the Clean Water Act, it's going to be talking about some of the improvements that we suggest be made to the Clean Water Act. So today's good news about the success stories. First presentation will be from Luke Trumbull. He's going to look at dam removal in Michigan. Then Chad Pezell will talk about the success of the Wetlands program in Michigan. Then Alyssa Riley will talk about MPS or Nonpoint source success stories. And then the last presentation will be by Mindy Steffler. It'll be on the Rouge River, and it's a success in the making. So we'll start with our presentation with Luke, and then we look forward to questions and answers after all 4 presentations. Thanks very much.
Thank you, Phil. Share my screen here. All right, you should be able to see my slides. As Phil described, I'm going to briefly go over some success stories related to dam removal projects in Michigan. So I'm advancing just a second. So first we'll start with a brief history of dams and construction of dams in Michigan. And I'll go over some of the general benefits of dam removal. And then we'll end with a case story on the Boardman River near Traverse City. So before I get into that, I just wanted to bring up this slide, which is kind of although Part 315 dam safety and the dam safety program are not Clean Water Act programs, there's a lot of overlap, and this figure kind of demonstrates, here where we have the dam, it's adjacent to regulated lakes and streams, regulated wetlands, regulated floodplains, with water quality and, some of the discharge things that we're going to hear about later would directly impact dams and systems that are dammed. So a little bit about history of dams in Michigan. This graphic is a little dated. It doesn't have the 2000s or 2010s or even 2020s, but you can see the history of the dam construction in the state. And you can see that there's a sharp increase around the turn of the century, what peaked in the 1960s, and then a very sharp drop off in construction of dams in the late 1970s, and that trend has continued into the 2000s with very few dams actually being constructed today. And some of the reasons for building dams are water supply, hydropower, navigation, flood control, and lake level control. And I bolded and capitalized recreation, because a lot of dams were built for one purpose and have kind of that purpose isn't being served anymore, and recreation is by and large most dams serve to form recreational impoundments as the primary purpose today. Here's just a map that shows the location of dams in Michigan. There's over 2,600 dams in our inventory, and that is not all encompassing. There are some that we don't know about, but you can see every dot on the map corresponds to a single dam. So they're pretty much everywhere. They're highly concentrated in, the southeast and southwest, and then kind of spread out a little bit more in the northern lower and in the UP. But dams in every county, and lots of them. So I want to go over some of the benefits of dam removal. The social and economic benefits, probably the biggest one is that dam removal eliminates hazard associated with dam failure, which we've learned in recent past and throughout our history of dam construction and operation that, when dams fail, the consequences can be really bad, both to, humans and public safety, but also to the environment as well. Removing dam eliminates the long-term O&M costs associated with the dam. It can reduce upstream flooding by lowering the water levels upstream of the dam, and it can restore that natural flood storage and attenuation that happens in floodplains and wetland areas adjacent to former impoundment areas. Some of the ecosystem benefits. Dam removal improves the movement of aquatic biota and, such as fish and other aquatic organisms. It improves habitat for those organisms, restores a natural flow regime and sediment transport to the system. And we've got a slide that kind of demonstrates the impacts of dams coming up. It can improve water quality, decrease water temperature, improve nutrient cycling and movement, and restores the natural channel morphology, which is just how rivers form in alluvial systems like Michigan. So this slide is a fairly common slide that we see in a lot of presentations about dam removal, and it just kind of gives a high level view of some of the impacts that were on the previous two slides. When a dam is constructed on a river, it kind of disrupts the flow and the transport of nutrients and sediment that occur, and blocks fish passage and degrades, fish habitat and things like that. And then, the flip side of that coin is, dam removal will kind of restore those functions, restore the connectivity and the stream functions, lower the water temperatures, and improve fish habitat and other habitats within the stream. With that, we'll kind of get into a quick look at a largely successful dam removal project on the Boardman River near Traverse City. Locally known as a River Reborn. To date, it's Michigan's largest dam removal and stream restoration project. It occurred in the Boardman River watershed, which covers 295 square miles in Kalkaska and Grand Traverse counties. The project include removal of 3 former hydropower dams, and it will also include reconstruction of the Union Street Dam, which is the farthest downstream dam on the system in Traverse City. It included active restoration of 3.4 miles of river stream and floodplain, which reconnected over 161 miles of streams and tributaries. And it also resulted in restoration of 250 acres of wetlands and 60 acres of upland in the former impoundment areas. This slide shows what the Boardman River watershed looked like pre-dam, kind of uninterrupted, flowing from west to east through Kalkaska and Grand Traverse counties, and ultimately outletting in the West Grand Traverse Bay in Traverse City. And it was known for being a cold water stream and having very good trout habitat pre-dam. But then comes settlement and logging. And so as people started to settle the area and log, the landscape around the river and the river itself changed drastically to support the logging industry. And next came dams. So this photo shows construction of the Union Street Dam as it was constructed in the late 1860s. And that was the first dam constructed on the Boardman River, and it's near the mouth of the Boardman into Grand Traverse Bay. That was the first of a series, then followed by construction of the Boardman, Sabin, Keystone, and Brownbridge dams. The Keystone Dam would later fail and wouldn't be rebuilt, but and the Boardman Dam was reconstructed, in its previous configuration in 1931. So Sabin, Brownbridge, and Boardman were all hydropower dams that around 2005 surrendered their licenses to produce hydroelectricity, and because of safety concerns. So subsequently, you can see that in 2007 to 2011, the impoundments behind those three dams were lowered, and between 2012 and 2017, the dams themselves were actually removed. So this is just a photo of the Boardman River watershed and the dams in modern times. So these were the three hydropower dams on the lower left that were removed. And then the upper left is the Union Street, which still looks like that today, but is planned for reconstruction as soon as they sort out some of the legal issues surrounding that dam. So here are some photos of what dam removal looks like. You can see this is a heavily engineered system using siphon pumps and bypass channels to safely lower the water level behind the dams, and so that channel restoration can occur. This was at Boardman Dam. And then once the water level is lowered, you can see that, the equipment kind of gets in the river and reclaims the river channel where it existed pre-dam, and then start constructing those floodplains that were either impacted by the impoundment or filled with sediment over the operational life of the dam. And this lower right is just kind of more when the channel is being constructed and the materials being stockpiled to the left. You can see there's actually a kayaker coming through. This is kind of, you can see the river channel taking form through the former impoundment area. So all of the bare areas used to be underwater. And now you can see that the river channel is kind of finding its relic channel, and the floodplains are being reconstructed. And here's what it looks like when they're all done. So this is with, the channel reconstructed with natural materials, wood and rock, to kind of mimic the condition that would have existed prior to the dam being constructed, and then floodplain benchings to restore the floodplain access and flood flow conveyance through the system, and then native plantings to kind of jumpstart the revegetation of the river corridor. And, in several years when the trees mature, it'll look like a dam was never actually there. So some of the key takeaways: many dams were constructed a long time ago to serve one purpose, and they no longer serve that original purpose. Many dams have or will soon surpass their design life expectancy. We've got a lot of dams in our portfolio that are over 50 years old, which is a typical design life for a concrete and steel structure, that may need significant rehabilitation or reconstruction in the near future, or they would create a safety hazard. And insufficient funds exist to maintain all dams in a safe condition. So in many cases, dam removal becomes the most viable solution. And, with the dam removal comes a lot of the benefits we talked about earlier, with restoration of the functions lost when the dam was constructed, elimination of the safety and flooding hazards associated with the dam, elimination of long-term operation and maintenance costs, and improvement of water quality and habitat in the stream. So Part 315 is set up to ensure that dams are removed safely if that's the decision that's made by the dam owner. And then the other resource programs, that we talked about earlier, are designed to ensure that the benefits of dam removal are maximized, and that the impacts of the aquatic resources are avoided. So with that, I think I'm going to turn it over to Chad Pezell, who's going to talk about the successes of our wetland program in Michigan.
Thanks, Luke. Let me just pull up my PowerPoint here. One second. Having trouble finding my PowerPoint. One second, sorry. Okay, sorry about that. Hopefully you're seeing my slides at this point.
Yep, you should be good, Chad.
All right, very good. Well, thanks, Luke, for the introduction. My name is Chad Pezell. I'm the GIS coordinator for the Wetlands, Lakes, and Streams program here in Water Resources Division of EGLE. I'm actually been around long enough that I started my career right around the time we were having the 30th anniversary of the Clean Water Act. So happy to still be here in the program and helping to move things forward. So I'm going to talk briefly about some of the successes we've had in the wetlands program in terms of curbing the overall loss of wetlands in the state. So just to start with a little background, wetland loss obviously is a huge problem in the state of Michigan, where we have some of the greatest freshwater resources in the world. And really the loss of wetlands on the landscape really sort of translates into ecological services and functions lost. So one of the purposes of my work and the work that I do in the program is to attempt to quantify some of these wetland losses that have occurred since pre-settlement times, and attempt to give us some context for some of those ecological services that we've lost. Wetlands are part and parcel to all water systems essentially in the state of Michigan. They serve all sorts of functions to society, services to society in terms of dissipating stream energy and avoiding flooding, trapping nutrients and sediments before they get to the Great Lakes and cause things like algal blooms in Lake Erie. Obviously sources of wildlife habitat. So really they provide to us a lot of services in terms of keeping our water resources clean and viable in the state. So what I'm going to talk about today really gets down to our wetland monitoring and assessment strategy. And the first three objectives that we outline in this report are essentially to inventory Michigan's wetland resources. And we do that through the updating and constant use of the National Wetland Inventory data. And I'm going to explain some of how we use that for wetland status and trends reporting in the state. And lately with the adoption of My Waters, we're doing a much better job of tracking all our permitted impacts, unauthorized impacts, and restoration measures as well. So we're really starting to get a good handle on quantity of wetlands in the state that were here originally, and the sort of wetland base that we have today. So sort of starting with the results and sort of the success story here. Obviously, it starts with a pre-settlement loss that was pretty significant. So Michigan originally contained around 10.7 million acres of wetland prior to European settlement. But by 1979, based on this work, we dropped that number down to about 6.5 million. That's about a 40% loss of our original wetland base in the state. So that's significant. And to those of us in the program, sort of represents the systemic causes of many of our water quality problems in the state. However, since the passage of the Wetland Protection Law in 1979, we've actually seen the rate of wetland loss decline dramatically. So we still had about a 41,000 acre loss between 1978 and 1998. But the rate of loss actually slowed when we looked at 1998 to 2005. So we went from losing about 1,600 acres per year between the 78 and 98 period, and knocked that down to more like 1,100 acres per year between our analysis in 1998 and through 2005. So that's a significant reduction in the rate of loss, about a third. And we're hoping that in our further inventory efforts as we move forward with this, that we'll see that rate continue to slow. So big success since the passage of our Part 303 and state assumption of the Section 404 of the Clean Water Act. So the way that we got to these numbers, we produced a wetland status and trends report in 2014. This is available at our website. If you go to www.michigan.gov/wetlands, Essentially, this talks about our methodologies and all of our results in terms of tracking the quantity and quality of wetlands in the state. So I encourage you all to check that out. So like I said, I've been around about 20 years in the program, and when I first came in, staff were still pulling national wetland inventory maps from file drawers and trying to use them to assess resource impacts and permitted and non-permitted projects. You know, a very, very good product produced in 1979, late 70s. But again, not as useful as you know, using this layer in a GIS system. And really, you know, because that data was done in 1979, by 2000, 2002, we had some great statewide imagery that we could use to update the National Wetland Inventory. So essentially, the first step was to take this more current imagery and start to look at what wetlands had already been lost between 78 and 98. Losses to farming, and then losses to infrastructure. Obviously, pretty big impact on that wetland complex in that particular area. That's actually the M6 interchange over by Grand Rapids. And you can see we've lost a significant amount of wetland in that area over time. So the status and trends report and the National Wetland Inventory update were really trying to get at that. Where have we seen losses in those 30 years? So one of the things that we did to sort of start this process was we needed a way to estimate original wetland locations pre-European settlement. We were able to do that utilizing hydric soils data from NRCS and some historic land cover data that's been produced by the Michigan Natural Features Inventory, to give us a really good base of understanding of where wetlands were pre-European settlement and what sort of acreage numbers we were looking at. So this was sort of the base of where we came up with the 10.7 million acres of original wetland. Looking at that and pushing it forward to our 2005 update, again, you can see we've gone from about 10.7 million acres to about 6.4 as of 2005, which again represents about a 40% loss, almost half of our wetlands. And probably not a lot of surprise that some of the counties most affected are down in that southeast part of the state, Detroit, Saginaw, where we've seen, you know, almost 100% loss in certain places. So obviously that has an impact on, you know, the ecological services that the remaining wetlands can provide. So looking at the period between 78 to 2005, essentially we moved from about 7.5 million acres in 78 to about 6.5 in 1998, moving down to about 6.4 in 2005. And you can see again, where we're losing the most wetlands is typically over here on the southeast part of the state. So still trying to reduce the weight of wetland loss in that area. You know, we did track as part of our status and trends reporting causes of loss or the agents of change. Most of the wetland loss that we studied was due to either agriculture or development, but there were also small losses due to things like logging and recreation. So there's been a lot of agents, you know, since pre-European settlement determined to remove these areas from the landscape. And we can actually track how those changes move forward through time. One of the great things we've done recently is we've actually made our status and trends report data available to the public via Wetlands Map Viewer. Essentially a one-stop shop for all our wetland spatial data in the state. And you can actually go in and produce status and trends wetland loss reports for essentially any geography in Michigan, whether that be for your individual watershed, municipality, county. We can get a pretty good estimate, you know, again, for the Huck 10 and the Clinton River, that we had 73,000 historic wetland acres down to 14,000 and the loss that represents. So trying to get this data out to stakeholders to be used, you know, when we're looking at further resource impacts to sort of gauge the historic loss that's already occurred in those areas. So one of my pet projects now is to continue this push. We've been working with Ducks Unlimited and U.S. Fish and Wildlife Service for the last 2 or 3 years to update our 2005 data to 2015 imagery. And some of the things that have happened in the 10 years between those two time periods is we've really obtained some really great remote sensing aerial photography, statewide LiDAR for 1 foot topography statewide. And it's really changing the game in terms of the quality of the mapping that we can do. One of the exciting things is that we're now also updating the national hydrography data set in the state. And we've actually brought those two efforts together along with the federal agencies and all the stakeholders to attempt to map these resources in a consistent way so that the wetlands and the streams are actually mapped consistently and cleanly. So looking at a statewide LiDAR DEM of this area here, you can see we can really get some great detail in terms of our water resources, the river channels, the wetland areas, what's high, what's low. And as it used to be, we really had NHD and NWI mapping these things in a vacuum. And many times the streams and the wetland areas really did not match up well. This is an example of where we're heading in the 2015 update. The boundaries are getting tighter. We're mapping less areas that are not wetland. And I think we're capturing more wetland than we ever have and in a better, more consistent way. So very exciting for the future. Our goal is to update the status and trends reporting every 10 years. So I'm hoping that, once this data is done, we'll be moving on to our next status and trends report. So again, I think that's all I have from the wetland side of things. And at this point, I'm going to pass it off to Alyssa Riley to talk about some success stories in the Nonpoint source program.
Great, thank you, Chad. Okay, thank you to everybody for attending today. My name is Alyssa Riley. I am the Nonpoint Source Unit Supervisor. So I'm going to talk to you about the Nonpoint Source program and some of the successes that we've had. First off, I want to start off by making sure that we're all on the same page by understanding what nonpoint source pollution is. Nonpoint source pollution comes from overland runoff, precipitation, atmospheric deposition, drainage, seepage, or hydrologic modification. Sometimes it's easier to describe what nonpoint source pollution is not. It is not a point source. And instead of coming from a singular known location, it comes from many diffuse sources. So when rain falls or snow melts, the water moves over the land and picks up sediment, nutrients, and contaminants and deposits that into our water bodies. The Nonpoint Source program comes from Section 319 of the Clean Water Act. The purpose of the program is to protect high-quality waters from nonpoint source threats and to restore waters impacted by nonpoint source pollution or causes. We do this by giving out grants to local entities, and we provide technical assistance, information and education, and we assist with compliance and enforcement. So we document successes from monitoring that's done through our grants, but also through monitoring that's done with our Water Resources Division staff. Since 1990, we have funded 955 projects totaling over $190 million that we've given out in grants, and that has resulted in over $100 million in local match. So it's pretty significant money. We're not talking about small change here. What I want to do is talk about some of the best management practices. I'll refer to those as BMPs that our projects install. And there's a wide range of what can be done with our funding to address nonpoint source pollution. We do pervious paving systems, and we can replace failing septic systems. We install rain gardens and other green infrastructure and low impact development practices. We can restore and protect wetlands. We do conservation easements. And so conservation easement places a deed restriction on a parcel of land, and it prevents that parcel from being developed. So that's one practice that we do that is a permanent protection. We can also install 2-stage channels and do various stream bank stabilization projects. We replace road stream crossings. And the picture here shows a before and after photo of a road stream crossing in the Rouge River watershed. We also do several agricultural best management practices that include things like cover crops, grassed waterways, manure storage structures, livestock exclusion fencing, tile line control structures. And this list is not exhaustive of all of the best management practices that our projects can do. It's just an example. And one way that we document success with our best management practices is we estimate the pollutant loading reduction that installing that BMP has on the environment. And we do that through a model, but I just wanted to highlight a few that are, I think, pretty impressive results. So over the course of the program, we have installed over 200,000 linear feet of livestock exclusion fencing, and that has resulted in we have the sediment, the phosphorus, and the nitrogen estimates listed there. So we've done over 20,000 acres of land in permanent conservation easements, almost 300 road stream crossing replacements, just under 1,400 septic system replacements. And so this is just a big picture highlight of some of the impacts that our program has had. Now, we in 2005 started documenting environmental success stories. We get our funding from Section 319 of the Clean Water Act, so it's a requirement that on an annual basis, we report our success stories to EPA. And over the course of this time, we have addressed a variety of problems and shown an improvement in a variety of water quality parameters, such as water chemistry, E. coli, sediment reductions. And what I want to highlight then is just a few brief case studies, giving you specific examples of some practices that we've installed and then the subsequent improvement in water quality parameters. So first, I'm going to talk to you about EGLE River stamp sand restoration that occurred in 2011, a Bradley Drain 2-stage ditch project from 2017, and a livestock exclusion fencing project in Cool Creek in 2021. So the EGLE River in the Keweenaw Peninsula is known for having stamp sands deposited on the banks of the stream. So there was an 8.5 mile reach that was listed for poor macroinvertebrate communities due to copper concentrations from the stamp sand deposits, which is a historic mining waste. And so we used our Nonpoint source funding and relocated the stream channel and removed the stamp sand deposits and then stabilized the stream banks and seeded with native vegetation. And so the picture there shows the before and after comparison. So a pretty stark contrast to the gray stamp sand stream banks to then being vegetated. And what this graph shows is the two different sites. The two bars on the left are from a site upstream of the copper source, and then this GLR site is downstream. The bluish bar is prior to, sorry, the light keeps turning off in the room here. The purple bar, the light one, is pre-restoration, and the dark purple is post-restoration. And so the copper concentration declined approximately 75% pre and post restoration. We also looked at the macroinvertebrate community. And so 2008 was prior to the restoration, and there were approximately 2 taxa that were found in that stretch of Eagle River and 6 individuals. And then you compare that to post-restoration in 2011, there were 17 different taxa found and 769 individuals found in that reach. The next success story is the Bradley Drain 2-stage ditch project in 2017. This is an example of a geomorphology success story. And so the picture here shows what this drain looked like prior to restoration. And it was estimated that erosion was occurring at a rate of 0.2 to 0.6 feet per year. And so we used Nonpoint source funding to install a 2-stage ditch. And what the graph shows is the shape of the channel. So the red line is a very incised channel prior to restoration. And then we went in and we cut the banks back and installed a shelf. So it increases the capacity for water to flow through there. And so the green line shows the post restoration shape of the stream channel. And there are the estimated pollutant loading reductions. And the pictures really show how this was successful. So the first 1 year after the restoration, the vegetation is starting to take hold, and it's even more stable by year 3. But the bottom picture shows that channel during a flooding event. And so even during a flood, all of that water is now contained within the channel instead of flowing up and over top of the banks and flooding the adjacent fields. And then the last success story I want to talk to you about is a Cool Creek livestock exclusion fencing. This is where we were able to show an improvement in E. coli concentrations. And so Cool Creek is shown by the blue line here, and the water is flowing northwest, and the 2 red stars are showing where our monitoring locations were. Now, this was a unique site because the livestock access was occurring on just this little part north of this road, and was causing high E. coli concentrations, and the stream banks were beaten down. And so we were able to sample upstream and downstream very close to that livestock access to determine the impact. So livestock exclusion fencing was installed in fall of 2020. And what we were able to show is that by having the fence installed, it decreased E. coli concentrations downstream from the access point during dry weather events, but there were still exceedances during wet weather events. And so what that's telling us is that the livestock exclusion fence was one step in addressing the E. coli, but we were still getting runoff from that field into Cool Creek. And these are the E. coli results here. And so just the top table is showing the E. coli prior to the fence being installed, and the bottom table is, the top table is upstream of the livestock access site, and the bottom table is downstream of the access site. Both of these tables are prior to the fence being installed. And so we'll just focus on the daily geometric mean column. And if the number is highlighted yellow, that means that it was exceeding our state standards for total body contact for E. coli. And so upstream from the access, there were no exceedances. And then downstream on 2 different sampling dates, our standard was exceeded. And if you then look over at the 24-hour and 48-hour rain columns, you can see that those were dry weather events. So there had not been precipitation prior to that sampling. And so then both of these tables are showing the results after the fence was installed. The top table is upstream of the access. The bottom table is downstream of the access. So again, upstream, no yellow boxes, so there were no exceedances upstream. And then downstream, we did still have 2 exceedances, but if you look over at the rain columns, those were wet weather events. And so the 3 that are not yellow, dry weather, and then we were getting an exceedance during wet weather. So still more work to be done, but it's a step in the right direction. And then, yeah, these graphs represent the 2019, which was prior to the exclusion fencing, and then the bottom graphs represent 2021 data, which was after the implementation. The water levels are relative to the lowest recorded water level during the study. The blue line in each graph is the trend line, where the gray shaded area shows the confidence interval. So the narrower the gray band, the more confidence in the relationship between the relative water level and E. coli concentration. The red horizontal line represents the daily total body contact water quality standard. So the downstream pre-installation relationship is weak, likely because the cattle enter the creek sporadically and it's unrelated to the water level. And the strong relationship between E. coli concentration and water level in the bottom graphs in 2021 indicates that high flow, which is caused by the wet weather, is causing elevated E. coli at both sites and is causing exceedances at the downstream site. So just to summarize then, the Nonpoint Source program has decades of documented successes, both for overall program successes and then individual water quality successes because best management practices have been installed. I also wanted to mention that we do document and track social success stories. I just addressed environmental success stories today. And so if you want to find out any more information about the Nonpoint Source program, there is our website, and then we have a link in there to our success stories. They're all posted on our website. So with that, then Mindy Stockler will be talking about successes to date in the Rouge River.
Thank you, Alyssa. Let's go ahead and get my screen up here. Okay. Is it showing my screen now?
Yep, looks good.
Thank you, Ryan. Good morning. I'm Mindy Stoffler with EGLE's Water Resources Division, here with you today to talk about the Rouge River. The first thing I want to say is I'm not the expert on the Rouge, as the work that's been done here extends far beyond my 18 years with the department. So I am happy to have Phil Argeroff here on our panel today, as Phil was a key person here at EGLE in ensuring that the work was completed over the last 30 or so years. So I hope that's okay to say, Phil. And also with us is Laura Verona, who continues some of that work today. So thank you both for being here and for your moral support. For those of you not familiar with the Rouge Watershed, it's located in Southeast Michigan. It's part of Wayne, Oakland, and Washtenaw counties. It covers 466 square miles and is home to about 1.5 million people living in 48 different communities. As you can imagine, this is a highly urbanized watershed with a lot of people and a lot of impervious surface. Additionally, the Rouge has a long history of industrial use, particularly in the lower stretch just before it's discharged into the Detroit River. In telling the story of the Rouge, I thought it was really important to go back in time to get a true perspective on how far we've come today. So hundreds of years ago, the region was made up of forests, wetlands, marshes, and grassy wet prairies. It was rich in natural resources, like valuable wood for lumber and animals for trapping. Due to this abundance, many people settled in the area and the population began to grow. By the 1800s, people were already beginning to alter the watershed by enclosing creeks, digging canals, adding dams, and diverting the water away from the river to use in mills. The Rouge River became an important shipping channel to move these materials worldwide with its connection to the Detroit River and the Great Lakes. So as the industry along the Rouge continued to grow near the turn of the century, the ships became larger and the need for a deeper, wider, and straighter river continued. And also, historically, the lower areas of the Rouge were prone to flooding which was also not conducive to business. And so the river was further altered. In this 1911 survey, you can see how the river was altered to include cutting off an entire section of the river and the large dredge project that would eventually become the boat slip for the Ford Rouge plant. You can see that the boat slip and the Rouge here in this photo of the Rouge plant. When the construction of the plant was finished, it was the largest automotive plant in the world. It was also revolutionary in the sense that raw materials like iron ore were brought in and finished cars rolled off. While the Ford might have been the iconic industrial symbol of the Rouge, many other types of industries produced goods along the river. Facilities like petroleum factories, salt, paper, fertilizers, as well as, of course, as the automobile, were all produced along the Rouge. And so thousands of gallons of waste from these businesses are largely discharged directly into the river without treatment every year. In addition, raw sewage combined with stormwater runoff was discharged directly into the Detroit and Rouge rivers without treatment. And what's really significant here is that the population of Detroit is close to 1 million people at this time. And as you can imagine, people begin to get sick. After some delays due to the economic impacts of the Great Depression, Detroit's first wastewater treatment plant is constructed in 1940 and begins to treat up to 40 million gallons a day of sewage. However, the infrastructure remains a combined system, with sewage and rainwater ending up in the same pipes. And when large rain events happen, the treatment plant reaches capacity and the combined sewage and stormwater is discharged directly to the rivers. So keep in mind that the area continues to be developed and the population served continues to grow. By the 1960s, the Rouge River is largely considered to be the most polluted waterway in Michigan. And on October 9th, 1969, the Rouge actually catches on fire after the Shell Oil Company spills about 3,000 gallons of oil to the Rouge. And what I found significant about this was that it wasn't even major news at the time. After all, Ohio's Cuyahoga River caught on fire like a dozen times, and pollution was largely seen as an inevitable byproduct of progress. Elsewhere in the country, the same scenario was being played out, as nationwide 2/3 of the country's waterways are rated as unsafe for fishing or swimming. And thanks to the Times Magazine highlighting the Cuyahoga River fires and the state of our nation's waterways, the public actually begins to demand change, and the first Earth Day is held in 1970. In 1972, the Federal Water Pollution Control Act is amended to form what we know of today as the Clean Water Act. The act required that point source discharges of industrial and municipal wastewater have permits, which limit the amount of pollutants that can be discharged. In 1973, the state of Michigan was delegated the authority to issue these permits and enforce compliance with the requirements. As these permits are being issued in Michigan and around the country, water quality did improve, but many problems still persisted. Suspecting that stormwater might be a cause, the EPA conducted a national study of urban runoff between 1979 and 1983, which confirmed that stormwater is a significant source of pollution. This information would later become the basis for the 1987 amendments to the Clean Water Act, which required permits for point source discharges of stormwater and also provided funding for the Nonpoint source program grants Alyssa spoke about. And so the same wet weather issues seen in the rest of the country are also seen here in the Rouge. While many of the industries and municipalities have permits and are largely meeting those discharge requirements, the problems still persist, particularly with combined sewer overflows. In the Rouge, there are 168 CSO outfalls, meaning that when the area receives enough rain, that combined flow is discharged to the river. Included in that are 37 outfalls that receive a significant amount of industrial wastewater from businesses, which also get discharged directly during those rain events. So in the Rouge, water quality standards are not being met, and fish studies conclude that the few fish species that actually live in the river are in poor condition, which is not surprising considering the habitat. And in the picture, you can see here how the Rouge is just incredibly channelized. And then just a quick timeline here on the Rouge. All of these conditions sort of come to a head in 1985 when a 23-year-old man fell into the Rouge River, swallowed some water, and contracted a rare fatal infection. Unlike the 1969 fire, this time there was a significant public outcry. The Friends of the Rouge is formed, and the first Rouge Rescue Day is held, where citizens start cleaning debris out of the river themselves. The Rouge is also designated as an area of concern, meaning that it's one of the most polluted sites in the Great Lakes region, and the Rouge Remedial Action Plan is written. So a little more background on the Rouge Remedial Action Plan, or Rouge RAP. The Michigan Water Resources Commission called for the development of a plan to restore the Rouge River by 2005, with the protection of public health being the top priority. It also identified a long-term goal of the river achieving water quality standards. Now, time frame wasn't put on this goal because I think in recognition of the massive undertaking this would take. So according to the report, the main problems in the Rouge were combined sewer overflows, stormwater runoff, illicit connections to storm sewers, contaminated sediment, log jams, and some other concerns. Some of the top priorities of the plan were sanitary sewer improvement projects, CSO control requirements, the elimination of illegal discharges to storm drains. So the total cost estimate to achieve these goals was $900 million over the next 20 years. So the Rouge RAP was important in that it led to the first significant CSO permits and SSO orders. And again, we're talking about combined sewer overflows and sanitary sewer overflows here. Unfortunately, these permits were legally challenged by permittees, which led to a long-standing court case. And the outcome led to the Rouge River National Wet Weather Demonstration Project and altered how the state addressed CSOs. So the Rouge project was a 22-year-long project and partnership between federal, state, and local agencies. The EPA issued a $350 million grant to be administered by Wayne County, with additional funding contributed by local communities and other stakeholders. The early focus of the project was correcting combined sewer overflows and the construction of several retention treatment basins, or RTBs. You can see an example of one of those RTBs shown here. And what these basins do is allow some of that excess flow that's produced during wet weather events to be held in the basins and screened, settled, and disinfected, and then discharged to a water body. And when the rain event ends and the flows are reduced to the wastewater treatment plant, any excess flow can be sent back to the plant for full treatment. So the Rouge project also recognized the need to work on restoring the watershed to a more natural system and included stream bank restoration projects, contaminated sediment removal, riparian corridor management, and green infrastructure projects. It also used a watershed-based approach to solving other significant wet weather problems like contaminated stormwater runoff, illicit connections to storm drains, and failing septic systems. The Alliance of Rouge Communities was formed in order to combat these problems and later utilized this approach to comply with the municipal stormwater permit requirements. A huge public education campaign was part of these efforts and resulted in citizen cleanups, volunteer monitoring, school programs, outreach to businesses, and numerous presentations. So the demonstration project resulted in some key water quality improvements shown here. There's increased quantity of fish and fish species found in the watershed, increased aquatic insect species, including the water quality sensitive caddisfly, improved dissolved oxygen levels, and decreased E. coli numbers. So moving forward to the present day, it really is remarkable when you think back to the pre-Clean Water Act Rouge, when there are virtually no requirements for discharges of wastewater or for stormwater. And 50 years later, all wastewater discharges have permits protective of the resource, which include long-term CSO control programs and pre-treatment requirements for those industrial discharges to wastewater treatment plants. And also significant are the hundreds of stormwater permits issued in the Rouge Watershed, which require pollution prevention strategies like housekeeping programs and material handling requirements, employee training, and the use of structural controls to keep stormwater clean. I also wanted to mention that the municipal stormwater permits not only have requirements for water quality, but water quantity. So the MS4 permit requires that stormwater management is addressed before development occurs through the site plan approval process. Examples most people are familiar with are stormwater retention ponds associated with development or green infrastructure practices like rain gardens. And so these things help keep excess rainwater out of the natural system and also allow for infiltration or filtration of pollutants out of the system. So in order to enforcing regulations, EGLE also issues grants to combat those non-point sources of pollution, which Alyssa highlighted in her presentation. Some recent examples in the Rouge Watershed are grants issued to retrofit parking lots in Plymouth with rain gardens. And by directing runoff into the rain gardens instead of storm drains, the excess flow and the pollution or the pollutants that stormwater flow carries are sent to the rain gardens and kept out of the Rouge Watershed. In the example shown here, you can see what a difference that makes, not only for stormwater, but also visually, and provides habitat for pollinators, and generally just looks very nice. It's estimated that up to 225,000 gallons of rainwater per storm event at the new rain gardens at the Plymouth Arts and Recreation Complex can be absorbed by those rain gardens, further keeping that out of the Rouge. One of the relatively recent successes in the Rouge is the continued improvement in dissolved oxygen levels in the watershed. So continuous DO monitoring during the summer of 2015 at 8 sites and branches of the Rouge River watershed found widespread attainment of the DO minimum of 5.0 milligrams per liter. Based on this data and the significant CSO elimination efforts, over 400 river miles of the Rouge River watershed had oxygen depletion removed as a cause for impairment. And so while a lot of improvements have been made on the Rouge in the last 50 years, there are still some remaining challenges. Untreated combined sewer overflows have been drastically reduced, but not yet eliminated. In contrast to that original Detroit wastewater treatment plant, today's facility is the largest in North America and can treat more than 4 times that original flow. CSO correction projects in the last 20 years have reduced untreated CSOs to 3 billion gallons in 2020. In addition to the construction of retention treatment basins, or RTBs, there have been multiple sewer separation and green infrastructure projects. Of the 17 remaining CSOs on the Rouge River, 7 high priority outfalls are to be corrected by 2037, with a long-term control plan update submitted in 2023. Of course, one of the other remaining challenges in the Rouge is legacy pollution. Remember back in 1987, when the Rouge was declared an area of concern, that meant that there was a long list of beneficial use impairments to be addressed. Unfortunately, none of them have been removed at this time, but that's not to say that no progress has been made. In fact, there have been many important projects completed to date, a couple of which I'll talk about here. One of those projects is the Rouge Oxbow restoration. If you remember back to the early days of the industrialization of the Rouge, bends in the river were removed to provide greater ease of transportation and for flood control. In 2002 through 2020, one of those oxbows was restored, which provided habitat for fish and other aquatic species, as well as stabilizing the stream bank and restoring those wetlands. Another important project involves removing contaminated sediment from the river. One of the most impacted sections of the Rouge is the lower Rouge Old Channel seen here. This project began in 2018 with the installation of sheet pile to stabilize the area in anticipation of the dredge project. So this is expected to pick back up next year and will remove 70,000 cubic yards of contaminated sediment and large debris, which includes, believe it or not, multiple vehicles. In summary, great strides have been made on the Rouge, and the next chapter in this story will need to include climate change impacts on our 20th century infrastructure, those long-term CSO and SSO control plans, the important work of managing post-construction stormwater through the municipal stormwater permit program, and of course, continuing to address that legacy pollution. So in closing, I think it's important to acknowledge just how far we've come in environmental protection, from literal rivers on fire 50 years ago to today, where we are regulating pollutants down to the parts per billion or even parts per trillion level today. I think when you look back on it, that's pretty amazing. And what's also amazing is the change on the river, which was largely written off as hopelessly polluted, to a resource that people kayak on today. I also wanted to thank my colleagues here at EGLE and WRD who work hard every day to achieve that long-term goal of the Rouge meeting water quality standards. And it truly is a team effort from our Nonpoint source and AOC program staff, our surface water assessment section, our stormwater inspectors, and our NPDES permit and compliance staff. It really takes all of us to achieve that goal. So thank you for all that you do. And now I think I'm going to hand this back to you, Phil, if you have any closing remarks you wanted to make on the Rouge, or we can pass it back to Ryan for questions.
Yeah, I think we'll pass it back to Ryan now for any questions.
Okay.
There's been so much improvement on the Rouge River, though, but we still do have a long way to go. But thanks for your presentation, Mindy.
Thanks, Phil.
Yeah, thanks, Mindy. Like we talked about here, we're going to go into a Q&A panel. So it'd be great if the rest of our presenters could turn their cameras on. And if you have any questions, everyone in the audience, feel free to type them in the Q&A box. We have a few here, and I'll just start to go through those, and I'll try to identify the best person to answer the question. But if anybody else on the panel wants to chime in or should be answering it, feel free to do so. All right, and I think this first one is for Alyssa. How are the model-based NPS BMP results validated? So that would be non-point source, best management practices.
Yeah, so we just use the STEP-L model. So it's the spreadsheet tool for estimating pollutant loads. And so they're just modeled estimates for those pollutant loads, but it gives us an idea.
Okay. Yeah, thanks, Alyssa. And I got another one for you here. What percentage of Section 319 non-point source funding is allocated to the inland lakes, Clean Lakes projects in Michigan? And then the second part is, what are examples of inland lakes projects implemented with 319 funds?
We don't do a certain percentage to inland lakes. We put out requests for proposals for our projects. And then there are several factors that go into selecting the projects. But one condition of getting an implementation grant is you have to be in an area that's covered by a watershed management plan. So that's the first step in that process.
All right, thanks, Alyssa. All right, this next one would be for either Mindy or Phil or Laura. What is the project that's currently taking place on Nankin Lake? Is it part of the Rouge Restoration Project, and is EGLE involved? Do you
I'm
know
not
anything about
familiar
that?
with that one.
Okay.
Yep, I'm not either. I don't know if Laura is.
No, I am not familiar with that specific project.
Okay.
I can look into it and respond back to the person asking.
Okay, yeah, I'll leave that one up. Thanks, Laura.
Yes.
This one is for Chad. Although the rate of wetland loss has declined dramatically since settlement, the losses continue. Can the losses be stopped and the wetlands recreated?
Yes, I think yes to both those questions. Our goal as a program has been to achieve no net loss over time. So at the very least, for any wetland losses that are incurred on the landscape, to recreate and mitigate those losses in wetland restoration projects. We have many partners that we work with in the state, NRCS, Fish and Wildlife Service, DNR, Ducks Unlimited, that do wetland restoration projects all over the place. We now have a mitigation banking project for regulated impacts to stem those losses. So yeah, I think as the program goes forward and we get better at quantifying, where these resources are, we'll be able to ideally in the future stop the losses and hopefully recreate some of the ones that have already been lost.
Awesome, thanks, Chad. I have another, I guess, question related to wetlands. I'll follow up with. How well do stormwater detention / retention ponds replicate the benefits of wetlands?
Well, certainly, they're designed to capture and store water, so to reduce flood flows. Obviously, when that water slows down and sits in those basins, it's going to precipitate out sediment and nutrients. But again, a natural wetland system provides multiple functions at that level, for providing the same service. So certainly we'd like to see, wetlands recreated on the landscape to provide that myriad of benefits whenever possible, as opposed to stormwater basins, but certainly those play a role too.
Okay, yeah, thanks, Chad. This one is going to be for Luke. Who funds dam removals and what criteria are used to prioritize which dams are removed?
That's a good question. So it's not, there's not a straight answer. The dam removal projects, depending on the size and cost, are funded through a myriad of programs, right? But I think the best answer is probably DNR Fisheries Division administers some state funds that can go towards dam removal. Our program, the EGLE Dam Safety Program, just did just receive an appropriation in FY22 to develop a dam removal or a dam grant program that can fund removals. So those are the two state sources, but several federal agencies as well have contributed. U.S. Fish and Wildlife, U.S. EPA, through a lot of the Great Lakes Restoration Initiative programs can fund dam removals as well. So that's kind of the typical, the big players, but typically we're talking about some private investment from the dam owner, the local community, maybe some local grants and funds that might also be available, and then those state and federal funds. And if it's a very large, expensive project, sometimes it's multiple of those sources to go and fund one project.
Excellent, thanks, Luke. Next question is most likely going to be for Phil, Mindy, and Laura. It's related to Oakland County. Besides the sewer expansion project planned for North Oakland County, are any other communities planning on using the new infrastructure money for sewer expansion? So I guess this is actually more of a statewide question. I guess maybe Phil, is there anything?
So Laura, I'm guessing that this is the project that's going to take some of those communities up to the Genesee County Regnone plant.
Same thing.
Yep, and so there's a lot of value in that project actually, because it's going to pull off some really underperforming and critical groundwater discharges as well too. So there's a lot of benefit for trying to regionalize the area in the northern part of Oakland County and pulling off some of those groundwater discharges and bringing those to a wastewater treatment plant to treat that flow. I can't think of any more for sewer expansions. I think most are for remedial type impacts, unless Laura, you know of any others.
So we don't have any per se sewer expansion projects to serve communities that are presently not served by sewers. Our Part 41 program issues construction sewers for sanitary sewers in the municipalities that I served. And a lot of that is just for development or redevelopment, but not necessarily expansion or reaching into communities that are not presently sewered.
Thanks, Laura and Phil. This next one is most likely going to be for Alyssa, but anyone else I think could probably chime in. It's pretty general. Which BMPs and its best management practices are the biggest bang for the buck?
Depends on what you're trying to accomplish. We really try to, the ones that cost the most are, we've done some pretty extensive stream bank restoration projects. But yeah, it really comes down to what the issue is. And we try to do BMPs that address the systemic source. We don't want to do something that, just makes a local fix when something upstream is still going to be causing some kind of impairment. So yeah, I don't think there's really a straight answer for that one.
Gotcha. Yeah, thanks, Alyssa. This one is for Chad. It's about wetlands. Can you discuss the quality of man-made or man-created wetlands as compared to the natural wetlands that are sometimes lost?
Yeah, that's a great question. Our priority in the program, typically when we're reviewing any sort of resource impact, is to prioritize preservation of already existing resources, just because the intricacy and the myriad services that those natural systems provide. We've got a lot of expertise in-house in our restoration and mitigation programs. The expertise in terms of putting these wetlands back on the ground and making them successful. I think we're just getting better at it as time goes on. But certainly, I'm not sure that anyone would say that we could actually recreate a wetland that functions as well as a natural setting that has been unimpacted. So we continue to work towards that. But again, our priority is always preservation of anything that's still existing.
Thanks, Chad. And this is actually the last question I have in here. So if anybody else has questions, feel free to type them in and we'll get to those as well. But the last one I have right now, this is kind of general, or if anybody knows about it, what became of the stamp stands that were removed from EGLE River? Anybody familiar with EGLE River and stamp stands that were removed?
They were, I think, yeah, I don't, it was actually, that restoration occurred before I was here. So I've just done the reading about the stamp stands. So they were removed and just taken off site and deposited in a safe way.
Gotcha. All right. I'm still not seeing any other questions at this point. So with that, yeah, thank you all. Thanks to all of our panelists and for all your great presentations, for everybody's asking those great questions. I have one final thing to go through before we wrap up. And that is, just want to give a little plug for our final webinar in this web series. It's on October 18th, which is not coincidentally the actual 50th anniversary date of the Clean Water Act. And that'll be at 11 a.m. And it's on the remaining challenges of the Clean Water Act in Michigan. You can access that webinar by going to www.michigan.gov/CWA50. You can access a registration from there. And then we will also, once we have the recordings from the other two webinars posted and up, we'll put them on that website as well. So you'll be able to catch the other two webinars that we did the first 2 weeks. And with that, I think that's all I have. Unless there are any final comments, I think we're going to wrap up. Last thing I have to say is that you'll be seeing a couple emails from me. One will have a link to a certificate for this webinar and a survey. So please give your feedback. We appreciate your feedback. And then the second one will have that link to the recording that will be on our YouTube channel. And with that, thanks again to everybody. Hope to see you at our next webinar, and I hope you all have a great rest of your morning.
Thank you.
Thank you.